Okay, in order to create our confidence intervals, it was necessary that we took a simple random sample that accurately represented CROP as a whole. So to choose which classrooms we would survey, we assigned each teacher on the CROP website a number, so we got 1 through 109 teachers. We then put this range into a random number generator, which gave us 3 different numbers, 68, 71, and 60. To minimize bias when we asked the students in the class, we asked them individually rather than as a class. So for example, for the tarpon topic, we showed each student a photo of the tarpon and asked them to identify it by name rather than asking the class as a whole who can identify a tarpon. Because topic 5, which was the average GPA of males in AP Calc, and topic 10, which was the average SAT for females, had a very small sample size, we chose to increase it by collecting data from the lunch. So to randomly select which lunch we went to, we flipped a coin and we got tails, so we chose to attend lunch 2. Then, to select the area of seating from lunch 2, we assigned each area of seating a number 1 through 3, 1 being the north patio, 2 being the south patio, and 3 being the cafeteria. After we generated number 2, which was the south patio, we used cluster sampling to assign each table a number 1 through 10. And then once we randomly generated table number 4, there were 19 students sitting there, but only 14 of them qualified for the topics that were being asked. So after we combined all these methods of sampling, our sample size came out to be 96 students, and we were able to proceed in making our confidence intervals.
As an example of how we calculated confidence intervals, I'm going to use topic number 1, which is the proportion of students who wear their natural hair color. So before you construct any confidence intervals, you need to check the conditions. The abbreviation for conditions is RNI, randomness, normality, and independence. So first, for the randomness, as Sam said earlier, we used a simple random sample for all of our sampling methods, so we ensured that the surveys were random. Next comes independence. So when you're constructing a confidence interval with proportion, the way that you see if the sample is independent is you do 10 times the sample size has to be less than the total population, which is the 10% rule. So our sample size was 82, so 10 times 82 is less than 2,700, which is the number of students at CROP, so we can proceed with the confidence interval. Last, we had to check normality. For normality of a confidence interval with a proportion, you use this rule, which is n times p has to be greater than 10, and n times q has to be greater than 10. So here I did the calculations. Our p hat, which we calculated, was 0.537. And that makes our Q, which is 1 minus P, to be 0.463. So when I did both these calculations, they both came out to greater than 10. So I was ready to proceed with our confidence interval. So the formula for a confidence interval with a proportion looks like this, which is the point estimate plus or minus z sub alpha over 2, which is the critical value, times the standard error. Now, the way you calculate standard error for a proportion confidence interval is the square root of p hat times q hat over n, where our p equals 0.537 and our q equals 0.463. Next, following the formula, we had to find our critical values and our standard error. So the critical values come from the standard normal distribution, and it tells you the area at the certain z-score. So here are the different critical values for 90% confidence interval, 95% confidence interval, and 99% confidence interval. Next, we calculated the standard error. So as I said earlier, the standard error is the square root of p hat times q hat over n. So when you do those calculations, our standard error was 0.055. So plugging this into the formula, we did p hat plus or minus each individual critical value times 0.055, and we got these 3 confidence intervals. So these 3 confidence intervals show you the range that we believe the actual population proportion P lies within, which each level of confidence. So for example, we can say with 99% confidence that the proportion of students who wear their natural hair color lies between 39.6% and 67.8%. Now, you have to make sure that for topics 5, 6, and 10, because they asked for the mean confidence interval and not one having to do with the proportion, you have to use the t-distribution because we don't know the standard deviation of the population sigma.
For our first topic reflection, we did it on the average GPA of male students in AP Calculus AB. For this question, we were relying on students to give their accurate GPA, which they may not have done. It was difficult to find students to survey for this question, as it's a very small population of the school that's in this class. So we also had to survey students during lunch in addition to the students we surveyed in classrooms. Out of the students sampled, the average GPA of male students in AP Calculus AB turned out to be 4.77, which we agree with this results. This is a high weighted GPA, but students who are taking an AP level math class are likely to have taken other AP level classes, which would have given them this high GPA. And then when surveying, we did not specify if we were asking for a weighted or unweighted GPA. This could have caused confusion, which led to bias, and caused our confidence interval to be inaccurate. Also, students might have just given a higher GPA to look good, so this also could have caused error. For a second reflection, we did it on the proportion of students who drink coffee in the morning before school. We found that the proportion of students who drink coffee in the morning before school is 33.3%. We agree with the results of this survey. It makes sense that over 25% of students would drink coffee in the morning before school, as students need extra energy as we wake up very early. This proportion might even be a little low. This question was confusing as it did not specify the amount of times that a student had to drink coffee in the morning before school to qualify to answer yes for this question. This could have caused bias, as a student who only drinks coffee once in a while might have answered no for this question, even though they do drink coffee in the morning before school.